The purpose of this demonstration is to show how the DUCO scavenger valve operates. What we're going to do is put coat hangers in the valve and do some shearing, and then we're going to show the individual parts in the backside of the valve to show you how everything performs or outperforms the other valves that we've been seeing on the marketplace. So we'll go from here, and what we're going to do is take a picture of the valve. We're going to close it. We're going to cut about 8 or 9 coat hangers and show how they don't plug the valve up, especially at the bottom part where most of the other valves are plugged. Go ahead and close it. You can see it, Dave, with my hand in the way. I'm going to put the coat hangers on the side. As you can see, it cuts all of them or shears all of the pieces. What I'm holding here are the 3 wear components of the DUCO scavenger valve. This is the seat ring, which has the serrations in it to assist in shearing, especially at 9 and 3 o'clock, so we don't shear all the material at 6 o'clock and put stress on the gate. This is the new profile design of the gate. It's also 420 stainless steel, heat treated and hardened. We removed the metal here to allow the material to fall out the bottom of the valve and not jam it into the bottom of the valve. And also what we have is a hardened 420 stainless steel lower guide ring, which allows the gate to ride on the hardened stainless steel instead of riding on the 317 portion of the gate, which would eventually wear it out. These 3 materials, Northport currently holds a patent pending, and we're in hopes of getting a patent sometime this year for these 3 components. This is a 10-inch cartridge on a 10-inch DUCO scavenger valve, and we just want to show you the serrations that are in the seat that assist in the shearing of the material, glass, wire, staples, the baling wire, and other materials that you get in the valve. Picture the valve, Dave. What we're going to do here is we're going to illustrate how the cartridge shears the material on the sides and not all the way at the bottom, so it'll start shearing the material at 9 and 3 o'clock and all the way down. You want to close it, Justin? Let's see what happens here. You got a good shot of it? As you can see, it sheared the coat hangers. This is about 16 coat hangers, and it actually sheared off the double wire, not just the single wire, but where it's intertwined. So that means it probably did about 30 coat hangers. Now what we're going to do is we're going to flip the valve over so we can show you the bottom of the valve and why, when it closes, there's a void area at the very bottom, so that we don't plug the valve up with the materials like glass and wire and staples and so forth. It's able to fall out the bottom of the valve, especially when you have the water wash and the vortex working. It helps clean the valve out even better than what we do when it's dry. See, we flip the valve over now on its side to show you that the area at the bottom of the valve, probably from about 8 o'clock to 4 o'clock or 5 o'clock, has a void area in it, so that as the gate closes, it shears the wire, pushes it to the bottom, and everything can fall out the bottom of the valve without clogging the valve up. And this is some of the wire that we cut off there. Now what we're going to do is open the valve, and I'm going to put some wire into the guide area to show you that the gate will push the material out of the guide area. It will not jam it in between the gate and the valve body. So let's do that. Justin, you want to? Oh, keep going. You can stop it there. I'll just open it. And we may. You still got it on?
Yeah.
We might have to do that. We'll put some wire, just like you get the glass and stuff in there. Put a few pieces, and then we're going to close it and show you what happens. You want to close it? As you can see, the gate pushed the wire out, and open the valve again so you can jam in there. Close it again. Alright, as you can see right here, what I wanted to show was the fact that we put a stainless steel lockout bar in every cylinder operated valve. All of the Scavenger valves come with a lockout bar and limit switch bracket. As you can see right here, every cylinder operated valve is also supplied with stainless steel limit switch brackets, which are adjustable for opening and closing. You put a set screw in here that's magnetic, so it'll indicate the open and close position. Also, you can see we have set screws on each side of our clevis nut, so that it's extremely tight, held tight and firm to the gate to prevent breakage or coming apart due to. I have here about 15 coat hangers. Yeah, open it up. Okay. That's the stuff I put in. You still recording? Go ahead and close it. Just to show you how the valve shears wire and staples and material like that. This is a 10-inch DUCO Scavenger valve. You can see that it'll go through about everything without plugging the valve up. And there you have it. That's my story, and I'm sticking. We have here the precision grinding machine being operated by Justin. And what we do here is we control the surface finish on the gate to about 2,000. So that we have a precision machine gate that doesn't plug up the DUCO Scavenger valve. And we do that on every gate that we supply in our Scavenger valve. It's really what makes the valve work. Good. You do that too. You ready? What we have here is an example of a North Port cylinder operator. The cylinder itself is a fiberglass carbon combination material that comes from Wisconsin. The bridge is aluminum, cast here in Stony Creek area. The top bridge is also aluminum. The piston head is aluminum. We have quad seals inside the cylinder. And if you have, the good thing about the fiberglass material, if you have wet air, you're not going to have corrosion. You're not going to have corrosion on the aluminum. Thus it makes our cylinder last a lot longer. And all of this is machined and made by Northport. We make cylinders from 5-inch diameter up to 20-inch diameter.